Hello once more, and welcome to our 58th test and measurement video. This is part 2 of a discussion begun in video 57, in which we demonstrated some interesting aspects of the amazing Fluke 8808A bench-type multimeter. Today we've connected it to another highly competent instrument, the equally amazing Tektronix PWS4305 Programmable DC power supply. This is appropriate because Fluke and Tektronix, both venerable instrument manufacturers who have built quality electronics test equipment for years, are currently owned by the same company, Fortive. With the Fluke's multimeter's red probe plugged into volts input and the black probe plugged into the grounded port, we have connected the probe tips to the Tektronix DC power supply's positive and negative terminals, and we have turned both instruments on. In the power supply, press V set, and using the keyboard, type in 12.000. Press enter and turn on the output. Using the knob, adjust the output to 12.00 volts. The Fluke meter reads 12.000. That's very close. The difference between the power supply output and the multimeter readout is less than 1/10,000th of a volt. Using Ohm's law in conjunction with the fact that 1 amp corresponds to the flow of 6.25 times 10 to the 18th electrons flowing past a given point in a circuit per second, you could calculate the number of electrons that would flow through various resistive loads in that time interval under the gentle prodding of 1/10,000th of a volt. In the quest for ever greater precision, we'll leave both instruments on for an hour or so that they warm up thoroughly and stabilize thermally. Then we'll repeat the above exercise. The temperature of both instruments has stabilized. Notice now that the difference between voltage output and of the power supply and multimeter readouts has declined. As another interesting demonstration, still connected to the 12-volt DC output of the Tektronix programmable power supply, let's read the AC voltage. This is a common measurement used to detect AC ripple in order to evaluate filtering in a power supply, which is critical in audio as well as many other applications. In this instance, the AC reading is around 0.235 millivolts, which again is a very small amount of electromotive force. In this actual power supply ripple, or are we seeing the noise floor of one or both instruments? For at least a provisional answer, press frequency in the Fluke multimeter. The readout indicates 0.00 hertz. So this would indicate that it is not ripple that we are looking at. Now is a good time to check out that row of white buttons just below the readout in the Fluke 8808A bench multimeter. They are labeled S1 through S6, and they can be used for storage and retrieval of up to 6 test configurations. This accelerates the process of meter setup, especially when repeating complex configurations. To save a configuration, press Shift followed by the desired function key. To recall a configuration, press the applicable function key. When a configuration is stored, it includes 17 measurement parameters, so sometimes this is a tremendous time saver. Thanks for watching. New videos are added periodically, so check back frequently.